Hello everyone. In this video, we're going to look about grid demand prediction management, a regression model. This model predicts energy demand using real-world data from smart meters. This data used for this model comes from a smart meter dataset, which include daily energy readings like energy median, mean, maximum. Okay, let's look into our model. Firstly, I have imported the necessary libraries which are required for our model. And next, I have loaded the dataset, which is a CSV file. And then a pre-processing steps. First, I am checking whether there are any missing values in a model dataset. Yes, there are missing values. I found some missing values in the column energy underscore S3D, which is standard deviation, right? Okay, to fix these missing values, I used a SimpleImputer from sklearn to fill the missing values with a column mean strategy. In this way, we can fill our missing values. And again, I'm checking if there are present any missing values, and no, there are no missing values in our dataset. Okay, next, feature engineering. Here, I converted the day column into datetime format to extract some useful features like the day of the week, month, and I also created is underscore weekend column, which identifies whether the day is a weekend or not, to make useful predictions. And next is dropping unnecessary columns here. Columns like LC, LID, R and day were not useful for predictions and were removed. Next is splitting the dataset. The data was split into input feature X and target variable Y, which is energy sum. Then dividing the training and test sets. Here have divided the training and test set into the ratio of 80:20, which is 80 for training data and 20 for testing data. And next is scaling the data. I standardized the data using a standard scaler to ensure that all features are on the same scale. This may be crucial because when it comes to a random forest algorithm, the random forest algorithm can perform better with the scale features. So I'm using standard scaler here to fit and transform the training and test data. Next is building the regression model. I used a RandomForestRegressor here, which includes 100 trees of estimators and a fixed random state for reproducibility. And I'm predicting my test data, and I'm using metrics, evaluation metrics, which is a mean squared error and R² squared error, to ensure the differences between the actual and predicted values. And here are my mean squared error and R² score. And next, I'm making predictions with new data. In order to predict with new data, I have to create a data frame and input values which will be same as my data set input. So I am using a new data frame, and I am using the data frame and transforming the new data and using some columns on it. Next, I'm scaling the data, which is I'm pre-processing the data to ensure consistencies. And finally, I'm making prediction on my new data. Prediction of energy sum values, which is our output, which is a target variable. So we are making predictions on it, and predicted energy sum values are here. Okay, in summary, we built a robust grid demand prediction model using a random forest regression. That's it. Thank you.